See how we get on. So if you were here on our Sunday live, you might recognize some of these questions. We'll have another Sunday live this week. This Sunday is going to be biology and physics. So first question's about the periodic table. What order did scientists use to arrange elements in the early periodic tables? So yeah, this first question we saw on Sunday. So we got atomic weight. So let me just get it up in the notes at the bottom here. So early periodic tables were organized by atomic weight. Yep, well done. So this topic is under the periodic table, which is in C1. So answer is atomic weight of the element. Excellent. Next one. In early periodic tables, some elements were placed in the wrong groups. Mendeleev overcame some of these problems in his periodic table. Complete the sentences. He did this by leaving gaps. Yep, I've seen this question come up all the time. It's always the same answer. He left gaps. So he left the gaps, and then other people filled in the gaps when the new elements were discovered. So because when he made the periodic table, there were some elements that didn't fit the gap. So he just left the gap there, and other people basically discovered those elements and found that they did fit the gap. Next one, what is the name of the group that contains argon? Argon. So let's take a look at the periodic table. Here's the modern periodic table. So this is what we deal with now. Argon is here. Group 0. Group 0 is known as the noble gases. Yes, well done, guys. Noble gases. So there's 3 names that you need to know. Group 1, Group 7, and Group 8 or Group 0. So Group 0 is the noble gases. What are the other 2? They're literally there in the question. So Group 1 is the alkali metals. And Group 7 are the halogens. Yep, well done. Group 2 is called the alkali earth metals, but they won't ask you that in GCSEs. So that's fine for that question. Okay, next question. An atom of argon is represented as this. This should be a 40. It's been cut off. It's a 40 and 18. Determine the number of protons and the number of neutrons in one atom of argon. Let me know what you think the answers are. Let me get it up in the notes while you do that. So this is the first topic. So the questions at the start are going to be easy. It's going to get harder as we go on. Like I said, guys, those of you who just joined, this paper, you can download this from our website. It's on the timetable. Right now we're going through the easier questions. Okay, so yep, I'm getting the right answers here, 18 and 22. 18 because the bottom number, as you can see from the notes here, is called the atomic number. That tells you the number of protons. The top number is known as the mass number. That's neutrons plus protons. So the number of protons is going to be 18. And then to work out the number of neutrons, here we've got it here in the notes, subtract the atomic number from the mass number. So we do 40 minus 18, which is 22. Well done. On to the next question. Different atoms of argon are this and this. So you can see here the top numbers changed, but the bottom numbers stayed the same. What's the name of these different atoms in argon? So the bottom numbers change. The bottom numbers stay the same. So that means protons are the same, but the top number, which is neutrons and protons, has changed. So the name of something that has the same number of protons but different number of neutrons is known as, yes, I'm getting the right answers, well done guys, isotopes. So I've got the definition here in our notes. Same atomic number, different number of neutrons, same number of protons, different number of neutrons. We call those isotopes. Not fullerenes, that's a carbon allotrope. Not ions, that's a positive or negative atom. Not molecules, that's more than one atom bonded together. So well done, those of you who got that. On to what are allotropes? Allotropes of carbon. So that's another topic. It comes under bonding. So this is stuff like diamond, graphite, fullerenes. So you can see it here in the notes. So it's all made up of carbon, but it's just different structures of carbon. So we've got diamond, graphite, graphene, fullerenes, and carbon nanotubes as well. They're all allotropes. Okay, next question. Yep, everyone's answering it correctly. Argon. So argon has 18 electrons. So as an electronic configuration, the first shell can only hold 2. Second one can hold 8. So that means the third one must also hold 8. So it's 288. Why is argon unreactive for 1 mark? Why is it unreactive? So it's something to do with the previous answer, with the 288. What's the reason for that? Yeah, it's in group 0, meaning it has a full outer shell. That's enough to get you the marks. Yeah, well done, guys. So that's the first question done. Next question. Our teacher said that we can't say it. What can't you say? It has a full outer shell? Yeah, you can. It has a full outer shell, literally in the mark scheme. That's the reason why it's unreactive. Has a or you can say it has a stable arrangement. You can say it has a stable arrangement of electrons, but yeah, it's acceptable. You can say full outer shell. What's the state symbol? Does that make sense? Let me know if it still doesn't make sense. What's the state symbol for oxygen? You can't say gas, yeah? You have to put this actual symbol. You can't put gas, you have to put G, because it's asking for the symbol. If you put gas, you won't get a mark. Next question. Figure 1 shows the percentage by mass of the elements calcium, carbon and oxygen in calcium carbonate. What percentage by mass of calcium is in calcium carbonate? What do you guys think? Look carefully at that pie chart. You can kind of read it off. You don't really need to work it out. I guess you can work it out. So I'll show you how to do that. You count how many, see where the dotted lines are? They're all split up equally, right? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's been split up into 10. It's asking for it's asking for calcium. Calcium is all of this. It's all of that. That covers 4 of the segments. So 4 out of 10. 4/10 is basically 40%. So the answer is simply 40%. Well done, those of you who've got that. Next question. At high temperatures, sodium nitrate decomposes into sodium nitrite and oxygen. A student heats 3 samples of sodium nitrate. The mass of each was this, 4.5 grams. The mass of solid after heating was recorded. Okay. So the mass, you can see the mass has decreased. It started off at 4.5 grams and it's decreased to all of these numbers. And the question is asking to calculate a mean of the solid after heating. So it's basically asking to find a mean of these 3 numbers. Can anyone do that? So to find a mean, you just add them up and you divide by the number. So do that plus that plus that. Anyone with a calculator? Do that and let me know what you get. So add them all up. 3.76 plus 3.98 plus 4.09 divided by 3. And we get an answer of yes. Well done, guys. All of you getting it. So I think in your calculator, you get 3.943 recurring, right? But the question is specifically saying 3 significant figures, which you guys have correctly done. But remember, if it ever tells you or ever asks you to do it to a specific significant figures, make sure you do it because it's an extra mark. If you leave your answer like this, you'd lose a mark because they've specifically asked you. So you need to put it to 3, which is 3.94. So answer is 3.94 grams. Okay, on to the next one. Table 2 shows the electronic structure of hydrogen and oxygen. Okay, so hydrogen has 1 electron, oxygen has 8 electrons, you can see here. What paper is this? This is a paper that I made myself. It's not a year, it's loads of past paper questions combined. You can find it on my website on the homepage. Just go down to the timetable. It's on the one that's marked 17th of April. Just go to paper download and you can see it there and you can go through it. I'll be doing my next one on Sunday here. You can see the paper there. Physics and biology. I did say it before. I said it at the start. You can download all of these here at this before any of the lives. You can download all of these before. But yeah, if you want to join my Sunday one, this is the code, and you get 20% off if you want to join that. On Sunday, we'll be going through a physics and biology paper. You can take a look at it before and join. It'll be similar to this. Yeah. So just screenshot that and save it if you wanna come and join the Sunday live. So next one. This is combined and triple. It's relevant for everyone. All the questions in this paper is relevant for everyone. Complete the dot and cross and diagram. Okay, so it says you should only show the outer electrons. So that's what we've got here. We've got 6 on the oxygens. We've got 1 on the hydrogens. Okay, so here they've already put a circle and a cross on this one. So this one's complete. We need to complete the oxygen and the hydrogen. This hydrogen is going to be the same as the other one. That's going to also be a cross and a dot. So the cross, we can say the cross comes from the hydrogens and the dot or the circle comes from the oxygen. In total, what's the number of oxygen electrons we should have? What is the number of circles we should have? So we should have 1 cross because the crosses represent the hydrogen electrons. The circles represent the oxygen one. Yep, well done. You should have 6 circles. We've already got 2 circles here. So we need 4 more on the oxygen. 1, 2, 3, 4. And then you just need to double check to make sure that you've got 8 electrons around each atom. We've got 1, 2, 3, 4, 5, 6, 7, 8. That's fine. Sorry, not 8 electrons, just full outer shells for each atom. So the oxygen's fine. Then for the hydrogen, you've got 1, 2, which is a full outer shell because it's the inner shell, which can only hold 2 electrons. And same with this oxygen as well. So all of them have full outer shells. So that is the final answer. Okay. Next one. Oxygen and sulfur are examples of simple molecules. Choose the sentence. Complete the sentence. Choose the answer from the box. There are what bonds between atoms of oxygen in an oxygen molecule? What do you guys think the answer is? So you can tell from this diagram here, what type of bonding do we have here? So you can see here, the electrons are being shared. So that's going to be covalent. Covalent bonding, well done. Yeah, so electrons being shared is covalent bonding. If electrons are being transferred, that's ionic bonding. Okay, next question. Figure 3 shows the relative sizes of an oxygen molecule and a sulfur molecule. So you can see here the sulfur molecule is much bigger. How does the boiling point of sulfur compare with the boiling point of oxygen? Okay. The boiling point of sulfur is, what do you guys think? So sulfur is much bigger in terms of molecule than oxygen. So what do you think that does to the boiling point? Sulfur boiling point is higher. Someone's saying lower. The answer is, why don't you guys tell me what you think the answer is? Let me get this up on the notes so I can explain. It comes under bonding. Comes under covalent compounds. Here we go. So it comes under the strengths of, it's all to do with intermolecular forces. So for sulfur, see here in our example, we've got chlorine and iodine. This one, the bottom one, has a bigger molecule because it has bigger atoms, which means its boiling point is greater. The reason why is because iodine atoms in this example are larger. So that means they've got more electrons, meaning there are stronger intermolecular forces between the molecules. So more energy is required to overcome them. Yes, well done, guys. That's what I'm getting as the answers down there. So in order to answer this, the boiling point of sulfur is higher, is the first word. So remember this, there's another question similar to this in a bit. But it's not a fill in the gaps one. Like I said, the questions in this get harder as we go on. This is because in sulfur, the intermolecular forces are stronger. Stronger. Well done, guys. Okay. Time for the slightly harder questions now. This question is about oxygen. So we've got an equation here. And we've got a reaction profile diagram. How do you know that? How do you know which one? The bonding is because they're bigger. The bigger they are, the stronger the intermolecular forces. The stronger the intermolecular forces, the higher the boiling point, because it's harder to break those forces. You see here we've got forces between the molecules. It's harder to break those because they're stronger, basically. Yeah. Okay, label the activation energy. Do you guys know where to label activation energy on these diagrams? Let me get it up. So if you ever get one of these diagrams, where would you label it? It's under reaction profiles. Yeah. So always here, from the reactants to the activation energy. Do not call it optimum point. Optimum is in biology, when you're talking about enzymes and things. You don't call it optimum in chemistry. This is activation energy. Just call it the peak. Yeah, you'll find the website useful. That's really good to hear, guys. It's completely free. So I suggest everyone have a look at it. It's completely free. It might be useful for some of you. It's got videos, it's got notes. It's got all the spec points for each individual topics. It's what you can see at the bottom of the screen. It's basically my website. Website is flashrevisionlab.co.uk. And you can look at all the notes for biochem and physics. How can you download the paper on iPad to write on? So that's what I'm doing right now. I go on the website and then so go on the website. This is the homepage of the website. Go down to the Revision Live timetable. So today's one, for example, is here, paper download. If you click on that, it'll open up and then you can press the share button. So press the share button, which is yeah, that symbol with a arrow looks something like this, doesn't it? And then go to open in, and then I've got an app called GoodNotes, and then that's what I use. So I open it in GoodNotes, and then I can write on it like that. Yep, thank you. flashrevisionlab.co.uk. Yep, thank you for sharing that. Okay, let's carry on with these questions. Determine the overall energy change for the reaction between hydrogen and oxygen shown in part A. So, overall energy change. Let's go back to our notes. Energy change, you can see here, the pink arrow here. Energy change goes from reactants to the products. So let's try and label that here. Reactants, let me get a different color. Reactants is here. And products is over here. So from here to here, that's the energy change. So we need to take that reading. What do you guys think that is? Yep, well done guys. So here this is 800, down here we got 300, so you just subtract the 2 and you get 500. Okay, on to the next one. So this question I think we went through on Sunday live as well. This is another one that we went through in our Sunday live. So those of you who came to that, you're going to recognize this question. So this is another covalent bond. Remember, covalent bond is when you share electrons like this. We got oxygen. It's in group 6 of the periodic table. So that means both of these oxygen molecules have 6 electrons. So let's represent that with 6 crosses. And 6 circles. Yep. So the whole aim of this is to have each of these, or let each of these have a full outer shell. Okay. So think about on the left hand side, we've got 6 electrons. How many does it need? It needs 2. It needs 2 to get a full outer shell. So what it does is it borrows 2 or shares 2 from this oxygen. So let's borrow those 2 and let's share it. So let's put those in the middle. So I'm going to put that in the middle. 1, 2 circles in the middle. Then same on the right hand side. The right hand side had 6. It needs 2 as well. So we're going to put 2 of these in the middle. 2 crosses in the middle. Now what's remaining? We got 4 crosses here. We got 4 circles here. So we can put 4 crosses here. 1, 2, 3, 4. And 4 circles. 1, 2, 3, 4. And that's the final answer. So we can double check that like we did before. Remember, they need to both have full outer shells. So they both technically need to have 8 electrons to show that they're full outer shells. This has 1, 2, 3, 4, 5, 6, 7, 8. So that's fine. And same here. 1, 2, 3, 4, 5, 6, 7, 8. That is fine as well. So that's the final drawing. I've got all the ones, or all the really important ones that they're likely to ask you here. If you go under covalent bonding, I've got a list of all the important ones that ask you. See, here you go. So the one that we just drew is this one here, the oxygen one. But all the other ones that I've seen in past papers, I've put that down as well. So remember, you can check this all out on the website. It's all free. So yeah, let me know if there's any other questions. On to the next one. Okay, we got a bond energy calculation here. So get your calculators out if you haven't already. This is going to be quite a lot of calculation. Let me get the notes out. So this comes under, I think there's a last topic in energy changes. Yep. So whenever it comes to these bond energy calculations, you have to remember it's bonds broken minus bonds formed. Bonds broken are the reactants. So that's all of this. And bonds formed is all of this. So let's do the bonds broken first of all, which is the reactants. You basically just need to count up all the bonds that there are in that one. So in the reactants, there's one bond in the middle, which is an O to O bond. O to O bond. So we look that up in the table. That's 138. So we got 138. If you guys know what to do, just work it out and just type what you think the answer is, and I'll tell you if it's right or wrong at the end. So we've taken this bond. We got two more bonds, which is this OH and this OH. Look at them carefully. They're both the same bonds. They're both an O bonded to an H. O bonded to a H. So they both come under this. So that OH is 463. But there's two of them, so we'll do plus 2 times 463. Now, one thing that people would forget to do here is look carefully here. We've also got a 2 here at the top. There's a 2. So you need to multiply the whole thing by 2. So let's put a bracket around that, times it by 2. Tell me what you get there for the top part. That's all the bonds broken. Where is the OO? OO is here, right in the middle. Can you see? Between the oxygen and the oxygen here, we've got an OO bond. So that's why we put the 138 in it. Let me know if anyone's got this answer. I'll write it in. Then we'll do the bonds formed underneath. So for the bonds formed, let's count this all up. Let's start with the easiest one, the O double bond. This one's the easiest one to do. So you can see here in the table, that's 496. 496 plus, now let's look at this water molecule. It's got 2 OH bonds. They're both OHs, OH and OH. So we'll do 2 times OH. OH is this, remember, 463. So 2 times 463. And then, don't forget, sorry, let me rub this out. Don't forget that in front of the H2O, we've also got a 2 here. We need to multiply that whole number, all of this one, this bracket, by 2. Not the 496, because there's only one of those. You need to multiply the 463 by 2. So let me see what questions we've got. Yeah, understanding it now. Okay, good. So I counted up all the bonds, and then at the top here, the numbers that we got at the top is 2128, I think, if you add up the top one. And the bottom one, yeah, I'll post this on YouTube tomorrow. The bottom one is 2348. Okay, and then remember, so look down at the website at the bottom, bonds broken minus bonds formed. So we need to take this top number, minus it by the bottom number. You should get a negative number, and the final answer, what did you guys put? Minus 358. No, any other answers we got here? Why are you multiplying the bond formed by 2 again? We're multiplying this by 2 because there's a 2 here. There's 2 of those molecules. So we've got to times it by 2. This is GCSE. Why did we times it by 2 times? Oh, okay, because, so let me go back to that. There are 2 OHs. There's 1 OH here, there's 1 OH there. So there's 2 times OH, so we did 2 times 463. Then we added the OO in the middle, which was 138. But then there's 2 of all of this, so we times the whole thing by 2 again. Okay, so if you subtract these two, you should get an answer of minus 220 kilojoules. Minus 220 kilojoules. Okay, any other questions before we carry on? So, yeah, if you want to practice this, I've got questions on the website. You can practice this one, we've got the website, and then you can look at all the past paper questions that they have on this topic. Just go into the questions tab, and look, we've got loads of examples here that you can try. Harder examples, easier examples. You can practice them, and then you can check the mark scheme. There, we've got the mark scheme for each one here. Tells you exactly what to do. Yeah. So yeah, the website is flashrevisionlab.co.uk. So definitely give it check it out after this. It's all free as well. You don't need to sign up or anything. You can literally just go onto it. So let me write down what it is. Flash Revision Lab.co.uk. And then once you've done a topic, so once you're confident with a topic, you can double check the spec points here. Tells you what you need to know for that topic according to the specification. And you can even watch videos if you want to watch my videos. Okay, let's carry on. Next one, group 1 element. Sodium reacts with chlorine to produce sodium chloride. Balance the equation. Right, so let's see. When you balance an equation, you want the same number of each element on both sides. So here right now we got sodium and chlorine. Sodium and chlorine. We've got 1 sodium right now. We've got 2 chlorines. On the other side, however, we've got 1 chlorine and 1 sodium. So they're not balanced. We want both of them to be equal. So yeah. Everyone's getting it right. So if you put a 2 here, first of all, let's put a 2 here to balance these 2 chlorines. Because we've got 2 chlorines here, let's make this 2 chlorines as well. That changes that to a 2, but it also changes the Na to a 2 because you've got to multiply that by 2. So now the chlorines are balanced, but the sodium's not balanced, so then you need to put a 2 in front of Na, which also makes that balanced. Well done. Can you write 220 without the minus? No. Let me check the mark scheme. Yeah, no, you'll get away with it actually. You can, but you in another mark scheme you might not be able to, because the answer technically is 220, so you should write 220. I think you're talking about this question, isn't it? So if you do get a negative, definitely write it down. But in this one, they let you get away with it. Next one. 4.6 grams of sodium reacts with chlorine to form 11.7 grams of sodium chloride. What's the mass of chlorine? So this is all about conservation of mass. So the mass before should be equal to the mass after. So it says 4.6 grams of sodium reacts with chlorine to form 11.7 grams. So conservation of mass means the mass of all of this should be equal to the mass of all of that. So, yep, Everyone's getting it right. You just need to subtract the two. 11.7 minus 4.6 grams, which gives you 7.1 grams. That's the correct answer. Next one. A teacher puts hot sodium into a glass jar of chlorine. The changes seen before, during, and after the reaction were observed. Complete the sentences. Sodium is a what solid? What color is sodium? It's just a metal, so what color do you think it would be? Yep, silver. Chlorine is a what gas? Does anyone know what color gas chlorine is? I've got it here. I'll show you. No, it's not colorless. Chlorine is not colorless. So chlorine, it comes under group 7, the topic group 7, which is under the periodic table. So we've got some people saying white. No, it's not white. Yes, it is green. It's green. So we've got, so you need to know the colors of the halogens. We've got the colors here. So you can see chlorine is green, yellow, greeny yellow here. That's green. Next one. Hot sodium burns with a something flame. Not lilac. Lilac is for potassium. It is yellow. Yep. Not white. White is white. That's for magnesium. Magnesium is a bright white light. This is a yellow. Yep. Well done. Product sodium chloride is a what solid? Sodium chloride. That's basically salt. That's salt that you put in your chips. So it's going to be, yep, white. Sodium chloride is an ionic compound. Write down the formula of the ions in sodium chloride. What do you guys think? Like, some people just like memorize it, but you can work it out from the periodic table if you're not sure. But here's the periodic table. So let me tell you guys, anything in group 1 is +1. Anything in group 2 is +2. Group 3 is +3. Then for 4 and 5, you don't really get asked that. You get asked group 6. The reason why is because group 4 and 5, they only sometimes form ions. Group 6 is -2. Group 7 is -1. And then group 0 doesn't form any ions. So screenshot that if you want to memorize it. So what you can do now, yes, now everyone's getting it right. So you can see sodium here is in group 1. So that means it's going to be +1. So Na+. And then the other one is chloride ion. You can see here is in group 7, so that's going to be -1 Cl-. Okay. Okay, we've got some, I think we've got some long questions after this. You've got a calculation in there as well. Next question. Potassium is more reactive than sodium. This is because potassium loses something more easily than sodium. What's that something? Whenever it comes to reactivity, it's always to do with electrons. Yeah, always to do with electrons. How does the size of the potassium atom compare with the size of the sodium atom? How would you do that? What you do is you'd look it up on the periodic table. So let's look for sodium and potassium. Here we go. They're both in group 1, sodium and potassium. Potassium is lower down. So yeah, potassium's larger. Well done. Reason for it then? What would you say for reason? So this gives you 1 mark. Potassium is larger. And the reason for that, this is triple and combined. It's relevant for triple and combined. As you go down, lower down, the atoms get larger. That is true, but why do they get larger? Yes, more shells. That's what gets you the mark. So it is because when they lower down, they do get larger, but the reason why is because they have more shells, more electron shells. There are more electron shells. What was the answer for E again? Answer was an electron. Okay, next one. This question is about elements in the periodic table. What order did sign? Okay, so this was in our first question, same question. Atomic mass? No. You don't say atomic mass. I'll tell you why in a second. It was the first question in the paper. Can anyone tell me why you don't say atomic mass? That's not right. Not atomic number either. You have to say atomic weight for this one. Why is that? This is the early periodic table. So before, right now, yes, we do use atomic mass. Everything in the periodic table has relative atomic mass in it. But before, in the early periodic tables, we hadn't discovered, yeah, well done, Harry. We hadn't discovered protons. So we didn't have any concept of protons, neutrons, and electrons. So we never came up with atomic mass and atomic number and proton number, any of that. So they used something they could measure, which was weight. So that's why they used atomic weight, which is kind of similar, but not exactly the same. So you have to say atomic weight for that one. In the early periodic table, some elements were placed in the wrong groups. Mendeleev overcame this. How do you do this? Like I said, this comes up all the time. Left gaps, yes. I see this question all the time in paper 1 chemistry. That's enough for 1 mark. Okay. Here we've got some boiling points here. Explain why the boiling points in the table are low. These are all the halogens. Can anyone tell me why? It's all to do with bonding. So let me get up in the notes. Let me know if you think you know what the answer is. Yes. Not diatomic bonds. There's no such thing as diatomic bonds. They are diatomic molecules. They have covalent bonds between them, but we don't call it diatomic bonds. Yes. Okay, so here, look at this diagram here. We've got 2 chlorine molecules. So chlorine is diatomic. They exist as Cl2. In between each chlorine atom, there's a covalent bond. In between the chlorine molecules, there's intermolecular forces. The covalent bond is strong. The intermolecular force is weak. So when you're trying to melt or boil these, it's not the covalent bonds you're trying to break. They're very hard to break. When you're melting these, it's the weak intermolecular forces you're trying to break. And because they're weak, it's very easy to break them. You don't need that much energy. So all of these have very low boiling points. You can see the negative, and that's very low as well. So it's all to do with intermolecular forces. You don't mention covalent bonds here because covalent bonds are not being broken. So for 2 marks here, you'd say there are weak intermolecular forces between the molecules. Don't say between the atoms, because remember, between the atoms is covalent bonds. Which need a low amount of energy to overcome. And that should be enough for 2 marks. And then, let me know if there's any questions. Next question. Explain the trend in boiling point. So let's look at this trend here. As you go down, what's happening? The numbers are getting bigger. So boiling point is increasing. Why does it increase? So we answered a question similar to this earlier, the one with the sulfur and the, what was it, sulfur and oxygen? We were comparing 2 different atoms. So increase boiling point, yes. So that will get you 1 mark. But we need to explain it. This is a 3-mark question. What else can we say? Why does the boiling point increase? Stronger intermolecular forces. Yes, exactly. Why are there stronger intermolecular forces? Because you need to mention that as well. So that's what I mentioned earlier. Here we go in our notes. And the website we've got here, because the molecules are bigger, the molecules have more electrons. So they have stronger intermolecular forces. Yes, well done guys. Everyone's saying the right answer here. So let's try and get those 3 marks here. So boiling point is increasing. So you actually, you don't actually get a mark for this. All the marks are for the explanation of it. So boiling point is increasing. Why? Because molecules get larger down the group. Next mark. What's the next mark? Let's see if anyone said it. So, atoms are larger, they contain more electron shells. You don't need to say more electron shells. That covers the fact that they're larger. The other thing, I think someone did say it higher up. If they're larger, it means there are stronger intermolecular forces. Yep, well done. Stronger intermolecular forces of attraction, which means more energy is required to break them. I think that should give you all the marks. 1 mark here, 1 mark here, 1 mark here. Yep, that's all 3 of them done. Okay, any questions on that? Okay, good. Next question, why is neon unreactive? Give the electronic structure of neon in your answer. Let's get up our periodic table. Let me know if you know the answer. You know, in group 1 is the same thing. Okay, let me answer that question actually. That's a good question. So let me get that up in the notes actually. So look at group 7. No. I think you get confused actually. You're talking about the reactivity. The reactivity of group 1 increases. The reactivity of group 7 decreases. That's because group 1 elements are trying to lose an electron, whereas group 7 electrons are trying to, group 7 elements are trying to gain electrons. That's why it's the opposite. Yeah. Okay, yeah, good, you got that. Yes, everyone's getting it right. It's 2,8. Look at where it is. It's only got 10 electrons. Electronic structure, you get 1 mark for saying this. 2,8. It's got a full outer shell. full outer shell. That means, yeah, it's unreactive. That's enough for all the marks. Okay, we've got one more question to do. So let me just let you guys know about next live is on Sunday. We'll be going through bio and physics. And here's a code for you guys. If you want 20% off, screenshot that. FRL20 gives you 20% off. You can access them all on our timetable. So these are all the remaining lives that we've got. So all the past ones, you can watch replays of them if you want. And then the one this Sunday, the physics and bio one here, you can download the 2 papers here and you can register for it here. Use this promo code and you can get 20% off if you haven't. Yeah, you checked the paper for chem last Sunday, but the paper was the same as this one. Yeah, I it's not exactly the same. It was slightly, I think there was 2 questions that was different, but I've changed it. I've changed the one for this Sunday. The paper for this Sunday should be different. Go check it now. I've changed them. So what time on Sunday? It's 6 to 8. 6 to 8 on Sunday. This code is only for the first 5 people, by the way. It's only for 5 people. So first 5 people to use this code, and then after that, it won't work. So yeah, one-time payment, just for this week. And if you like, then you can come to the other ones after. It's like every Sunday. So those ones are the longer lives. I'll be going through two subjects. So whatever subject we don't go through on TikTok. So here we did chemistry. So this Sunday I'll be going through physics and bio. Next week will be physics on TikTok and then bio and chemistry. So whatever ones I don't go through, I'll go through on Sunday. So that'll be longer. And yeah. So just screenshot that code if you're interested. And like I said, it's for the first 5 people. And yeah, so it would only be £4. It's not even that expensive, guys. Full price is £5. Will I be doing morning lives before the exam? So I might do. I'm definitely do one the day before the exams, the evening before. I'll definitely do that. And then the morning before, because both chemistry and bio are both on mornings, aren't they? They're like at 8:30. So it would be a very early morning live. What I'll do closer to the time, I'll ask you guys whether you'd want one or not, and then based on the responses, I'll do that. Any tips? Like I say all the time, go through the notes. Try and write down things as you go through the notes. So, like here, go through all of these notes. Anything you don't understand, or anything that you're learning new, write that down on a piece of paper. And then try questions on it. Try exam questions on it, on that specific topic. Check the mark schemes and work your way through all the questions. And then once you've done all of that, double check you know everything. Check the spec. Just double check all the points. And then, and then move on to the next topic. And then once you've done all of that, then start past papers, full past papers, and that's the way to do it. And then if there's stuff that you keep forgetting, just keep going back to the topic and doing the same thing over and over again. Like that is honestly, that's the best way to do it. You just need to keep going back and write the notes down. You retain more information if you actually write the notes down rather than just reading the notes. Write it down and try to properly understand it. The website's not money. The website's completely free, guys. Everyone go onto it after this live. Go onto it. It's completely free, and I'm getting like loads of good feedback from it. So honestly, try it out because you don't lose anything by going onto it. Just try a few topics, and once you're done with the topics, just you can mark it as complete. So let me do that here, and then it checks it off and it tells you how much of the topic that you've done. Website is called Flash Revision Yeah, so like I said, this is completely free. So go on to that, track it, and then for chemistry, for example, I think you just need to go up to this topic here. So 5.1.4. So before when's the chemistry? I think it's 17th of May. So if you can get to 5.1.4, mark that's complete, before the 17th of May, then that's all of chemistry paper 1. And you can do the same for bio, chemistry and physics. So it's all doable, guys. You have a lot of time. You have a lot of time to get all of that. So definitely check out this website. Like I said, guys, it's completely free. All right, that being said, it is just science. Yep, I only teach science, so I unfortunately don't have any subjects on it right now. Maybe that's something I might do in the future. We'll see. Oh, A-level resources? No, not right now. I literally spent the last few months making all of this. It took so long. Imagine writing all of these notes out. I had to write all of these. I had to draw all of these as well. It took me ages. It took me months and months. So to do an A-level one, that's going to take me another few months. So I won't get that done right now. So we'll see. I'll think about it. I might do A-level ones. Yeah, I made this myself. Yeah, I went through the whole specification, all the specification points, and I started making notes because I teach. I'm a tutor. So I know the whole syllabus, like pretty much back to front. So I just thought I'd make these notes, and draw all of these diagrams and everything. Yeah, it's free, completely free, guys. I want to make revision simpler for everyone. That's the aim. So that's why I made this website. Thank you. It's good to hear. It's good to hear that it's useful because I'm hearing a lot of positive feedback. How do you do the more question on top? Yeah, so I'm going to do the more question now. Yeah, thank you guys. It's good to hear. So, last question. How many atoms are there in 1 gram of argon? How do we do this? Any ideas before I go? One gram of argon. So moles. 1 mole. Or what's the equation for moles? Yeah. So moles is equal to mass over mR. All right. And they've given us Avogadro's constant here. What does Avogadro's constant tell us? Let me get that up on the notes. Moles. Moles, a measure of amount of substance. Here, Avogadro's constant here. 1 mole of any substance has the same number of particles as Avogadro's constant. So in 1 mole, no, not the mass of 1 atom. No, you would say 1 mole has this many atoms in it, this many particles in it. Okay. So 1 mole has that many particles. The question is asking how many particles are there, or how many atoms are there in 1 gram. So what we need to do is work out how many moles there are in 1 gram. How do we work out the number of moles in 1 gram? Well, we use the equation for moles, which I've written down. We've got it here in the notes as well. Moles equals mass over mR. So let's put those numbers in. Mass is 1 gram. mR, we've got that here, 40. 1 gram over 40 is going to give us the number of moles. 1 over 40, what does that give us? Is it 0.025, I think? 0.025 moles. Yep, well done. So 0.025 moles. So in 1 mole, so remember the definition for 1 mole, there are 6.02 times 10 to the 23 atoms. That's the definition of 1 mole. But what we have here is 0.025 moles. Yeah, so what you need to do is you need to times by 0.025 on this side, and you need to times by 0.025. So you just need to times, yes, well done, everyone's getting it right. So 6.023 times by 0.025, which gives a final answer of 1.51 times 10 to the 23.